Hello, everyone. It's pleasure to be here for our ASRM webinar series. So, as you know, that we are more focused in IVF now for the sperm selection and embryo selection for AI-based. But of course, that especially for egg banking, also the first level of embryo development, as we know that oocyte morphology has a critical role. So that's why as largest egg bank, one of the largest egg bank, we are focused on also for oocyte selection by artificial intelligence. So I will try to explain about our technologies, how we are predicting for oocyte morphology, how we are making the algorithm by AI, and how we are distributing egg between different location and patient by the AI help. So, as we are focused on AI, now AI is a trending for different area, especially for the medicine, the clinical work, and also, of course, in IVF for assisted reproductive technologies. As all sites, it's really important as a morphologically to have high quality oocytes, as all embryologists are understanding that for better embryonic development, high successful of fertilization, also significantly impact of conception rate and healthy pregnancy for the future. So as AI implemented now in IVF, especially to our IVF laboratories, for the efficiency of the oocyte selection, embryo selection, sperm selection. So we are more focused on here for the oocyte selection. So this is the part that which we should understand. We established as a data set, which data set has a patterns for undetectable by the human eyes some component into the oocyte as a mathematical algorithm and measurement for which is very important for reproductive clinics. As with this presentation, we will focus on different biological concepts, context, technologies, and advanced way which we can make the validation of the AI for the ethical consideration, why we should use AI or how we should use AI, and also the application of AI by the oocyte selection. So as a biological context of the oocyte selection, firstly, we are focused on, of course, the morphological and morphokinetical criteria of the oocytes. So the physical characteristic as shape, size, perivitallin space, diameter of the oocyte, the different cytoplasmic contents, even spindle, zona birefringence, and also from the site efficiency data for the embryo development outcomes, the pregnancy, and even live birth. So as here means significant way for the selection to don't keep only morphological criteria, but keep in sight also the clinical criteria, which is important, especially for egg banking. While, as we know very well, even high efficient of the egg donor still can create an issue for low quality of the blastocyst or low outcome of the blastocyst development. So our aim to use AI help also determinate in a site to know the efficiency of the egg donor. While as an embryologist, we can select the best quality of eggs even under stereo microscope or under invert microscope. But still, if donor has a low efficiency, we understand that those donors still can give low blastocyst outcome. As AI technologies in reproductive medicine has a different way as a machine learning, image analysis, and also data-driven insights. As a machine learning, the many information we are giving to machine, and machine can provide us high efficiency or high mathematical algorithm and calculation. As image analysis, we can put on a background millions of the image, which we are going to work with the similarity, significant similarity way of image analysis. So you can score millions of the embryos or oocytes with the different scoring by the senior embryologist, by the guidelines and journals, and finally on the database when similar image captured by the AI, so AI can detect and score this image as previous image context. So that's why the more image giving us more accurate result and also more efficient result. So the data which we are putting on the background, on the machine learning, this data always should be developed by us. So we are calling the machine learning, but still it is human depending. What we can use to build this system. So the first base of AI, we're connecting directly to the time-lapse microscope. So if you have a time-lapse microscope, as we are calling embryoscope, which is making high-quality image video recording, so you can implement AI, and AI can predict or detect based off images. But of course, we know that every laboratory, every clinic doesn't have time-lapse or embryoscope technology, so it's high invest, high cost, and there they have multi-locations, as Ekbank has many multi-production centers. So how we can make this more cost-effective and useful? Of course, this can be with the optical systems. As you know that invert microscopes has regularly one prism. So this prism can give image to your camera and also in the same time to ocular, and by the objective you can see this image or this live video. So here, if we add additional prism, additional lens, that means we can see the image as a 3D perspective. So what will give us as an advantage to give 3D image to AI? So that means we can measure different components as a precisely. For example, polar body. If you get the direct image to put to AI, AI will calculate only one shape, one side of the polar body, but it will not be exactly mathematical calculation. This will be only based off similarity on the background of images. But once you have two polarizer inside or two prism inside, that means you can get image from 3D side. So the mathematical calculation will be more accurate. So this is the way how we can use AI for morphological oocyte selection. So this is the study how they use mathematical algorithm to measure different components. We use the totally similar algorithm for calculation, for mathematical calculation, and those calculation may give us precise result for different axes and components as well. So here, as you see, the prism is making the image, single image, and this image can compare by the AI for similarity testing, because in the background still we have thousands of images which we score them in advance, and we know the scoring of these images. When AI captured by the prism as a 3D images, they start to calculate on a background as a mathematical component for different component, as a polar body or perivital space or the diameter or even spindle size and location. So our AI algorithm is not including only morphological specification, while morphological specification can give only morphokinetic based off the result. But our AI system also including donor clinical information. That means when we select the oocyte as a morphologically by AI, then in a site, AI technology will inform us also the clinical information as age and body mass index of egg donor, previous cycle of the efficiency, stimulation protocol, also height and weight of the egg donor, which is important from the phenotypical and efficiency side. As we know, from the left side, as you say, the three of the cats, you cannot say which is more sweet than another, so all of them looks amazing. But an oocyte is not like this. As we know morphologically, that each oocyte has difference as a morphokinetic level. That's why that oocyte parameters we should evaluate as a donor oocyte quality and the quantity. So for that, our AI system focused as mostly zona pellucida thickness, as we are calling birefringes, perivital space, the first polar body appearance, the shape, the meiotic spindle, and also the time-lapse activity. So the perivital space, as you know that perivital space has a big importance, especially for egg banking while we are using cryoprotect and So when we have a large perivitalin space, that means more amount of the cryoprotectant we can keep on the cytoplasmic area. So when we thaw these oocytes, that can create high level of toxicity for the oocytes, and that can create issue for the cleavage arrest. When perivitalin space absent, that's in an opposite way. So less amount of cryoprotectant will be affected because there is no place for cryoprotectant to take a place as to exchange with the water. So that will create also an issue. The mostly such oocytes, when you thaw, so they will get a bigger and they will get degenerate. So you understand that there is absent perivitalin space here. And those information, morphological information, has directly connection with low survival rate after the thawing. As first polar body, one of the components which we are focused on, because especially for egg banking, it's very important when you get the donor eggs, should be smooth, single, and compact polar body. So that question can be now like why we cannot detect under stereo microscope or invert microscope the single compact polar body, why we need AI for that. Actually, that is partially true. Yes, we can detect single smooth polar body, but different size of polar body, according study, gives different morphological and morphokinetic outcome. So that's why to measure the polar body and to keep in exactly in the reference value will give us advantage for more blastocyst outcome. So imagine that you, as a patient, you get 6 donor eggs, which cost high, and from these 6 donor eggs, you are expecting several blastocysts. So that means each oocytes for you potentially should give some blastocysts. So that's why each oocyte should have potential to give blastocyst for egg banking. That's why each component is very important to detect and check well. As zona pellucida in oocyte. So why we are focused on also zona pellucida? This is another important criteria, especially for fertilization and also implantation, because zona pellucida thickness, as we are calling birefringes, has direct connection, especially for blastocyst outcome and implantation. So how it comes? So as you see on this image, when you check the zona pellucida with polarizer, so this additional software which you should have on your invert microscope with the double prism, so you can detect spindle and zona birefringes. So on the left side, when you see high zona birefringes with the totally purple color, that shows that zona has exactly thickness. And when you make fertilization, you may see easily cytoplasmic breakage. That also give you advantage that those oocytes will be possibly give high quality of the blastocyst. And low zona birefringes, these oocytes either will not survive after warming, either if survive, will be degenerated after ICSI fertilization during the sperm injection, or will be cleavage arrest. As results shows, statistically, high zona birefringes always giving higher pregnancy and implantation rate comparing low zona birefringes. As you see here, how we are measuring all these components under the regular invert microscopy. So over there, we detect already spindle, as you see. We detect already polar body and also zona birefringes, which you see that zona is losing power over there. So this part, that means giving that potentially chance that this oocyte will give low quality of blastocyst or will not give blastocyst. So we should exclude this oocyte from egg banking. As morphological assessment of oocyte, so we should evaluate several key parameters. So those parameters of evaluation is a critical. So we have to measure the parameters as the oocyte diameter, cytoplasmic granularity, and also presence of the polar body, which is important. As a common methodologies, so we have standard methodologies which is included under the light microscopy, which we can make image based of the technology to detect the as the morphokinetic components. As the role of imaging here is a very important, as I said, more image will give more accurate data, but from another side, the quality of image very important for us during the AI, while, as I say, the 3D image, if you apply or if you supply 3D image to AI, so that you will give high and accurate outcome from the AI. So there are, of course, advantage and limitation even for machine learning. While it's connected with the image quality is connected with the dynamic of image, also there are limitations based of the technology. So integration of the AI, it's a totally different component. While it was firstly just possible with the time-lapse microscopy, but we already upgraded that and we put chance to AI to use on the regular microscope, even partially on the stereo microscope. So basically how data requirements for the AI, we are making a data collection. So the comprehensive data should be collected and kept on the database, which is quantitative parameters are important to checking AI algorithm, which is capable for predictive analytics. So data set should be labeled. So this data set, that means we already have in the background, which we already evaluated, which we already checked, and which we can use for identification and also for outcome. And also we have to be ensuring the data quality, which we put on the database as a data. This data should be evaluated by different embryologists and already scored by different embryologists as a different category of scoring systems. So that we are calling the optimization of the AI. As type of algorithm here, we are using different type of machine learning algorithm, which can also insight to compare the different result for the different way. That means there are different scoring system, morphological scoring system. So on the embryonic level, which embryo I'm saying 4A, another embryologist is saying 4AB. So also the morphology of the oocyte. So I can find one oocyte as quality 1 criteria, but another embryologist can detect that as a quality 2. So we have to catch some optimization and balance here. So how AI is doing that? This is depending how we build the parameter for the AI and standardization. So as validation of the AI models in oocyte selection, as you see here on the images, so we detect already different polar body qualities and we score those polar body qualities and we give importance for the validation of all these scores. So according to this matrix, we get high success or sensitivity. So as different cases have different results. So we have to build many different cases over there. It's not just a single image, also group oocyte image, as you see here. And we have to teach AI how AI should catch on each oocyte, which component we want to measure or which component we want to check it. As here, biggest concern is the ethical concerns, because each technology or techniques we are implementing to our labs, our first concern should be if really using that for patient benefits. So side of financial benefits, we have to use that really accurate for patient benefits. So this should increase the clinical quality of the selection, and it should help to patient to improve the result. So that's why we have to have informed consent. So patients should understand that this technology will really help. From the morphological base, they will have high quality of oocyte, and those oocytes will bring them some clinical benefits. So another things that amplification of the decision making. So they should understand that decision will be done by AI partially, but the final decision still on the human as a lab professional. So we will still accept which oocyte should be used for egg banking. So if we go only morphological based, that will be totally depending of the machine learning and mathematical calculation. But as professionals, we know that very well. Everything is not connected with the mathematical calculation, while here there are different components as clinical efficiency, also donor history or patient history as well. So as future direction, of course, that data set for each AI system. So for the different companies, they are making different AI systems. So the data set should be improved. So more data will give us more accurate result. So this is like a potential advance, which is giving to us to compare our AI with the different base of the technologies. So what is the challenges and limitations for current AI models? As a limitations, the basic limitation what we have, the study of number of study is limited. So number of data set are limited. So that is creating an issue and question if AI really successful for morphological selection. That's why as a different regulatory in the different countries, has no roles now on the AI selection in the reproductive medicine. So there are no regulatory at the moment which clear up where we can use AI and how functional we can use the AI. How we have built our system. So as you see over there, when you put the donor code or when you try to select the donor in front of embryologist, such screen is coming. So the embryologist will detect morphological outcome. So AI already separated which egg should be quality 1, which egg should be quality 2. But in the same time, this donor has already some outcome as a 3 cycle. So immediately system will bring in front of embryologist this outcomes. So what was the previous attempt this donor had already? What was the clinical criteria of this donor? What was the efficiency as survival rate or blastocyst rate? So when embryologists select, let's say 10 high quality of eggs, but over there as a cycle efficiency on the second cycle, there is no pregnancy from donor, 20% of blastocyst rate and 60% of survival rate. Of course, this donor is not efficient for egg banking. So this is kind of alert for embryologists. Even if this donor has high quality of eggs as a morphologically, this is not right choice for egg banking. That's why I was saying that ethically, the technology which we are building should be site of patient benefits. If we freeze this oocyte for patient, that's true that morphologically ideal. That's true that this oocyte maybe will survive all, but finally this patient will not receive a blastocyst, and it's still a big question. So as a final selection, how system is morphologically selecting. So we have different parts which we are trying to measure as a polar body, zona pellucida, spindle, and perivitelline space. And we give already, according to guidelines, some reference values. So after the measurement, AI is checking those measurements if we fit with the reference values. So we are selecting those oocytes as for egg banking. If not, so that means this oocyte is not for egg banking. So according to results, so oocyte selection by artificial intelligence and embryologist, what is the difference? So basically the similar number of oocytes, which we analyze with as a grading by the 2 senior embryologists and AI, we can easily find out there's 10% of difference between embryologist and AI. So basically those embryologists select additional 10% oocyte which can go through egg banking, but AI said no, those oocytes still not eligible for egg banking. So also we find out through AI selection, there are several advantages which can increase also the blastocyst rate, even the euploid rate. So the connection is here, not because AI can detect which embryo is euploid, of course no, but AI can detect which oocyte can give morphokinetically potential embryo, same as which embryo by the AI selection morphokinetically developing better. As we know, the morphokinetically, if embryo developing better in each stage, during the 6 days of culturing. So those embryo has more euploidy potential comparing others. Of course, beside there are different chromosomal structure, or if patients are bringing some genetic abnormality from the history, this is beside of this. So according to all of this, of course, as you can have high result for multi-center outcome as an egg bank, which is not connected only as depending of human, because we still can miss a lot of information, but AI can optimize this information. Still, AI is under our control because it's machine learning, and we are teaching all the time, and we are getting more data all the time. While we are adding more accurate data set, images, and information, so AI will give us more precise results. As AI-based oocyte selection advantage, so of course, biometric calculation will create a statistical algorithm, and which we can have morphological oocyte efficiency for each individual cycle. So also time-lapse mode, which you can connect it with AI, especially for egg banking. If you vitrify oocytes, you can record vitrification, you can record warming, even for straw loading process that can create more transparency for egg banking. And information may be received by the AI from the different sources and can be used for the algorithmic calculation, and it can be in a very short time, less than a minute. So also recorded image and time-lapse videos will be very helpful, which is the final customer towing those oocytes, and they will understand if there is discrepancy for or problem between the freezing and warming as well. So as a conclusion here, that oocyte selection is a critical, especially for egg banking, and we have to be precise and more accurate. And AI can create an algorithm to us to be accurate. There is potential improvement for AI, of course. So this is depending of more study, more images, and more data set. So once we will become the billions of the picture, we will have more accurate data, more accurate AI, and maybe we will trust much more. So still in a site, as an embryologist, we have to control all this process, but AI creating for us is a step that we can find out in the same image all components and all results. So the way how we can improve this, so many different sources, scientific sources should create different research, different image database, different scoring system, and finally we will have chance to optimize the final AI system for oocyte selection. So thank you very much for your time and attention.